8th chapter, differential equation. This chapter belongs to mathematics 2b part 2. Last part completed important definition, differential equation, order and degree of differential equation completed. Next, important formulas of degree and order of the differential equation completed. Today discuss somewhat different model problems. What is the first problem? Find the order and degree of the differential equation of the family of all circles with their centers at the origin. Centers at the origin. Family of the all circles. All circles family center having what here? Center having origin, radius are different. Suppose we have to take center origin, center h comma k and radius r. What is the circle equation? X minus h whole square plus y minus k whole square equal to r square. In this family of circles, center is what? Origin. Nothing but center h comma k equal to origin 0 comma 0. You can write h value 0, x minus 0 square, y minus 0 square equal to r square. Then x square plus y square equal to r square. Here r is a arbitrary constant or r is a parameter. You can write anyone. Why? Because here r values are increased, r values are different values. Why? Because this circle having number of circles. The center origin circles having number of circles, but the radius are different. That radius here arbitrary constant or parameter. In this parameter, this is the one key point. This point is very important. If any family of the curves, how many arbitrary constant is there? That time you can derive to that family of the curve. Suppose one arbitrary constant is there, only one time derivative order is 1. Two arbitrary constant is there, you can derive to 2 times of that family of curve. That's why here only r is there, only one arbitrary constant is there. You can derive to only one time, eliminated that arbitrary constant. That is the aim of in this problem. First, you can derive to this one, x square derivative with respect to x. Derivative of x square plus derivative of y square is equal to derivative of r square. Derivative of x square is 2x. Derivative of y square is 2y into dy dx of y is equal to derivative of r square. Nothing but r square is arbitrary constant, that is 0. That's why here one time derivative you can eliminate r. That way you can do that in any family of the curve. 2 arbitrary constant is there. You can derive to that family of the curve 2 times. After that eliminated that 2 arbitrary constant, you get the differential equation. That's why you can write 2x is equal to minus 2y into dy by dx. Here 2 get cancelled. Remaining constants, remaining x by minus y equal to dy by dx. Then dy by dx is equal to minus x by y, dy by dx plus x by y equal to 0. This is the differential equation. In this differential equation, arbitrary constant is not there. Why? Because you can derive to one arbitrary constant one time, you can eliminate that arbitrary constant. This is the differential equation. In this differential equation, order. What is the order? 1. Degree. You don't know find degree, but I find degree. Degree is the highest power derivative. Power is called degree. That is also be 1. In this way, you can find a family of the different curves. Next problem is obtain the nothing but differential equation which corresponds to each of the following family of the curves. In this differential equation family of the curves, first problem is the rectangular hyperbola which have the coordinate axis as asymptotes. The equation of the rectangular hyperbola whose coordinates are the hypotenuse Asymptotes is xy is equal to c square. C is a arbitrary constant. Arbitrary constant or parameter. Already explained. One arbitrary constant is there. You can derivate only one time. That time you can eliminate it arbitrary constant. That's why you can derivate one time. Derivative with respect to x. D by dx of x into y equal to d by dx of c square. Here uv formula you can write u into derivative of y plus y into derivative of x is equal to constant derivative is 0. After that you can write x into dy by dx plus y into x. X derivative is 1 equal to 0. Then x into dy by dx plus y equal to 0. This is the differential equation of the in this rectangular hyperbola whose coordinate axes are asymptotes. The family of the curve differential equation is what? X into dy by dx plus y. In this family of the curves, C arbitrary constant can be eliminated. Only one time you can derivative. What is the order of this one? This one is order is 1. This one is degree also be 1. Order also be 1. That is degree also. But in this way you can do that family of the curves. Next problem is the parabolas, each of which has a latus rectum 4a, and whose axes are parallel to x-axis. Whose axes are parallel to x-axis, latus rectum is equal to 4a. Here see students, in this equation you get the parabola chapter in geometry. That chapter explained briefly. Directly you can write formula. What is that formula? The parabola, equation of the parabola, latus rectum is 4a and which axis is parallel to x-axis is y minus k whole square is equal to 4a into x minus h. In this equation, h comma k are arbitrary constants. Here how many arbitrary constants is? Total 2. One is h, another one is k. These two are arbitrary constants. In this way, you can 2 times derivative this one. First one time derivative with respect to x. D by dx of y minus k whole square equal to 4a into d by dx of x minus h. Here 4a is common. After that, u power n formula. What is that formula? N into nothing but 2 into y minus k whole power 2 minus 1. 2 minus 1 into derivative of y minus k is equal to 4a into derivative of x minus derivative of h. Next 2 into y minus k whole power 2 minus 1 value is 1. Derivative of y minus derivative of k is equal to 4a into derivative of x is 1 minus derivative of h nothing but constant value is 0. That's why you can write 2 into y minus k equal to derivative of y is dy by dx minus derivative of k equal to 0. 4a into 1 minus 0 also be 1. After that 2 into y minus k into dy by dx is equal to 4a. Understood or not, friends? Understood or not? This is the equation 1. This one is equation number 2. After that we can write this. Suppose you have to take this one is equation number 2. Before 2 ones are 2 goes you cancel. Y minus k into dy by dx is equal to 2a. Y minus k into dy by dx is equal to how much here? 2a. After that, this is equation number with respect to x. One second derivative, you get with respect to x, you get what? 2 plus d by dx of y minus k into dy by dx, you can write y1. Correct or not? First here, differentiation chapter explained. Derivative of y, dy by dx, that is also we can write y1 or y dash, anyone. That is equal to 2 derivative of 2a. Here you can use uv formula. Y minus k into derivative of y1 plus y1 into derivative of y minus k equal to 2a derivative is what here? 2a nothing but constant derivative is 0. That's why you can write y minus k into y1 is the first derivative. first derivative, again derivative, that is second derivative. You can write y2 plus y1 into derivative of y minus derivative of a equal to 0. Y minus k into y2 plus y1 into derivative of y. You can write y1 first derivative y1 minus constant derivative is 0. y1 into y1 you can write y1 square. Y minus k into y2 equal to y1 square equal to 0. Then y minus k into y2 equal to y minus k into y2 equal to this place goes to that side minus y1 square. After that you can write y minus k equal to minus y1 square by y2 substituted. This y minus k value substituted in equation 2. This y minus k value substituted in equation 2. 2 implies, what is the value of y minus k? Y minus k value is what here? Minus y1 square by y2 into dy by dx value is what here? Dy by dx value is what here? y1 is equal to 2a minus y1 into y1 square into y1 cube y by 2 equal to 2a. You can write minus y1 cube equal to 2a by 2. You can write this one is 2a by 2 plus y1 cube equal to 0. What is the meaning of y1 cube? y1 cube meaning what? y1 cube meaning the derivative of first derivative of y whole cube. That's why you can write dy by dx whole cube plus 2a into y2. 2a into y2 nothing but second derivative. You can write dx square by dx square y by dx square. This is y2 equal to 0. In this derivative, order is what? Order is second derivative. 2 arbitrary constant is there. You can take 2 times derivative. That is order 2. Degree is 1. In this way you can do that. In this family of the curve equation is not given. That equation you can identify, you can write. After that how many arbitrary conditions you can write. After that you can derivative, then find a differential equation. In this type of question coming to the IP examination, unexpected 2 marks. Next, today assignment problems are homework problems. First problem, the parabolas having their foci or foci at the origin. Foci at the origin and axis along the x-axis. Axis along the x-axis. In this model problem, coming to the parabola in these equations, that parabola chapter explained briefly. First you can write directly formula. That is what? The equation of the parabola having the foci is origin and the axis is along the x-axis is y square equal to 4a into x plus a. Here a is a arbitrary constant. A is a arbitrary constant. This is one. After that you can derivative one time, eliminated a, you get differential equation. That is the answer. This equation you can write 1 mark, derivative you can write 1 mark. Total 2 marks. After the second one, the circle which touches the y-axis at the origin. This equation also be coming to the geometry part in this circle. Directly I can write directly equation. The circle which touches the y-axis at the origin. Touches the y-axis at the origin equation is x square plus y square plus 2gx equal to 0. Here g is a arbitrary constant. The g is what? Arbitrary constant. You can derivative one time in this equation. You can eliminate it. G, you get differential equation. This is the second hint of the second homework problem. This is the equation first homework problem hint. Third homework problem. The ellipse with the center at the origin and having coordinate axis as axis. Ellipse center having origin. This equation is the standard form of the ellipse equation. In the standard form of the ellipse equation, explain the ellipse chapter in geometry. What is that equation? X square by a square plus y square by b square equal to 1. A value is greater than b. Here a comma b both is arbitrary constant. Here a b both are arbitrary constant. Then you can derivative in this equation family of the curve 2 times derivative, eliminated a and b, you get a differential equation. In this way you can do that family of the curve. First you can find the equation of the family of curve. After that how many arbitrary constant is there, that time you can derivative that curve. You get a differential equation.